Good morning students. Heat transfer conduction, growth of ice layer on ponds. So atmosphere temperature reduced 0 degrees centigrade. The water in the lake also will be start the freezes. Start the freezes at any time t. Why is the thickness of the ice in the lake? Why is the thickness of ice in the lake? This is why. Why is the thickness of ice in the lake? The temperature of water will contact to the lower to the ice. And A is the area of the lake. A is the area of lake. So here heat escaping of the ice at any time dy. So dq is equal to Ka theta minus of minus theta into dt by y. So here K is the coefficient of thermal conductivity, A is the area of cross section, Y is the thickness of ice, and dt any time temperatures difference. So dq equal to Ka theta 2 theta into dt by y. So here heat escaping through the ice and dy is the water contact with the ice, that is equal to dq equal to ml. M is the mass of the substance, L is the latent heat. So M is equal to volume into density. So volume equal to area into dy. So dq equal to, so here rho into A dy into L. So here dq equal to Ka theta into dt by y. Y is the thickness. dq is equal to Ka theta dt by y. Then dq plus Ka theta dt by y equal to rho A dy into L. So A cancel. So here K theta by y equal to rho into dy by dt into L. So K theta by rho L into y is equal to dy by d theta. So reciprocal d theta by dy. So dq is equal to ml, dq is equal to rho A dy into L. So dq is equal to Ka theta dt by y. So K theta by y, A cancel. K theta by y is equal to rho into dy by dt into L. So K theta by rho L y is equal to dy by dt. So reciprocal, that is a dy by dt equal to rho L y by K theta. So dt equal to rho L by K theta constant. So y into dy. So into both side applied integration dt equal to integration rho L by K theta into y dy. So this is constant. So integration dt is equal to t is equal to rho L by K theta into y square by 2. Y is the thickness of ice. So here first point, time taken of thickness of ice. So double and triple in the ratio, that is equal to T1 is to T2 is to T3, that is equal to 1 square is to 2 square is to 3 square, that is equal to 1 is to 4 is to 9. Okay, here is the thickness of ice. To double and triple will be ratio, that is equal to 1 is to 4 is to 9. So time taken to convert the thickness of ice, intervals y2 to y1 intervals to y2 to y1, that is equal to y2 square minus y1 square. So delta data. So time taken thickness to convert the thickness of files, intervals from y2 square minus y1 square. The intervals y1 to y2 square minus y1 square. So thickness of files to convert time taken to convert thickness of files to intervals 0 to y, 2y to y, that is equal to delta t1 is to delta t2 is to delta t3 equal to 1 square minus 0 square is to 2 square minus 1 square is to 3 square minus 2 square. So time taken to convert the ice intervals, delta t1 is to delta t2. So intervals 0 to y2 0, 2y to y, 2y to y, that is equal to 1 square is to, so 1 is to 3 is to 1 is to 3 is to, that is a 1 is to 4 square minus 1 square, that is a 3 is to 9 minus 4 5, so on 1 is to 3 is to 5, 1 is to 3 is to 5. Next to convection. Convection. So heat transfer from one place to another place, actual movement of particles of the medium, difference of density, that is equal to convection. So heat transfer from one place to another place, actual momentum of particle of the medium, okay, difference of density, that is a convection. So convection is the important of the liquids. Okay, predominantly convection takes place fluids more than the predominant of the liquids. So Hg, mercury, heat transfer from conduction only, do not convection. Mercury heat transfer conduction only, do not convection. So convection two types. One is the convection two types. One is the natural convection or free convection. Second one, forced convection. So convection two types, natural convection or free convection, and second one forced convection. First of all, natural convection. What is the natural convection? So natural convection. So here fluid particles move from one place to another place, that is a temperature difference. Fluid particles move from one place to another place, temperature or density difference, that is called the natural convection. So natural convection, rising temperature, okay, and gravity is important in the natural convection. So here examples, trade winds and monsoons, sea breezes, land breezes, also natural convection. Next to forced convection. So here fluid particles are forced to move by external force. That is a pump, fan, external agent, pump, fan and blower is called the forced convection. So forced convection. Next, coefficient of convection. Coefficient of convection. So coefficient of convection, that is equal to P is equal to Q by T, that is equal to HA into delta T. So here H means that is a coefficient of convection. Coefficient of convection. A is the area of the fluid, area of cross section of the fluid. Delta theta, temperature between surface and fluids. Temperature between surface and fluid. That is a coefficient of convection. Next, radiation. Radiation. So here radiation, heat transfer from one place to another place without any material medium, that is called radiation. So heat transfer from one place to another place without actual movement of material medium. Okay, without any material medium, that is called radiation. So in radiation, fast process of conduction and convection. Heat transfer radiation to move in vacuum also. Heat transfer radiation in move to the vacuum also. So radiation is the hottest. All the compare that convection and conduction. Convection and conduction. So next one, thermal radiation. Thermal radiation. So heat transferred by means of electromagnetic waves, that is called thermal radiation. Heat transfer from that means of electromagnetic waves, that is called thermal radiation. So here nature and importance, nature and properties. Radiation energy. Radiation energy. So here consider, so radiation energy high wavelength. Consider radiation energy have high wavelength. That wavelength nearly 800 nanometer to 4 lakhs nanometer. So 1 nanometer equal to 10 power minus 9 meters. Okay, so this exists in the higher region of the electromagnetic waves, electromagnetic spectrum, higher region of the electromagnetic spectrum. The velocity of the radial energy, that is equal to 3 into 10 power 8 meter per second. So intensity of the radiation energy is directly proportional to, inversely proportional to square of distance. So intensity of radiation energy inversely proportional to square of distance. So I is proportional to 1 by r square. So I is equal to Q by A into T. That is I is equal to, is proportional to 1 by, so pi r square area. So I is proportional to 1 by r square. So intensity of radiation obeys the inverse square law. Intensity of the radiation obeys the inverse square law.